In section 3.7, we're going to solve percent problems. These can get a little tricky, and so we want a systematic approach to solving these. So first of all, what is percent? Well, think about cents in a dollar. There are 100 cents in a dollar. There are 100 years in a century, so percent simply means per 100. For example, if we have 57%, that's the same as saying 57 per 100. And we can use this to help solve percent problems. So if we write percent as a ratio like we did here, we can set up a proportion and solve for an unknown quantity. And we want to look for keywords like percent or is or of in these problems to know where to put various quantities in our proportion. And generally speaking, it's going to look like this. The percent, as usual, will go over 100, and that will be equal to another ratio. The of part we can call the base of that ratio. The is part is the part of the base. You'll see examples in a moment here. Another way to look at that is part to whole. Percent to 100, is to of, we can think of as part to whole, even though the part can actually be bigger than the whole sometimes, and we'll see examples of that as well. And then, as I mentioned, we can also talk about part of the base over the base. So if we looked at a problem like this, what percent of 50 is 20? What percent means we don't know the percent, so we can substitute x for that. And then of 50 means 50 goes in the denominator of our second ratio, is 20, 20 goes in the numerator. And then we can cross multiply if we want. X times 50, or in other words 50x is equal to 100 times 20 is 2000. Divide each side by 50 to get x equals 40, which tells us that 20 is 40% of 50. And it's always a good idea to go back and check and see if this is reasonable. 40% is a little less than half, and half of 50 is 25. Well, 20 is a little less than half of 50, so this seems reasonable. And an older, more traditional approach, we're often going to look at the wording and note that is will generally tell us equals, and the word of, very often, not always, but very often, it will tell us to multiply. And so in the same example where we look at what percent of 50 is 20, percent of 50 means we're going to multiply that percent, and we don't know what it is, so x times 50 is 20 means equals 20. So x times 50 we normally would write as 50x equals 20. Divide each side by 50 to get 20 over 50, which you can simplify first to 2 over 5, or just go ahead and divide 20 by 50, and you'll get 0.40. Then to convert that to a percent, remember we need to move the decimal 2 places to the right. We also have something called the percent equation, which looks like this. A equals p percent times b, where we could read this as A is p percent of b. So is tells us where the equal sign goes, of tells us to multiply. Again, not always, but generally speaking. In our first example, identify the percent, the base, and the part of the base in the following statement. 36 is 30% of 120, and it might even help you to write this. 30%, you don't have to write this proportion, but it might help. 30%, 36 is, so 36 goes in the numerator, of 120 tells us that 120 goes in the denominator. So the percent, that part is pretty clear when you have the percentage symbol right next to it. The percent in this case is 30. The base is the denominator of our ratio that doesn't involve percent, so that's 120. And the part of the base is the numerator of that ratio, which is 36. Number 2, what percent of 80 is 16? So what percent, we don't know what we have over 100, equal to of 80 tells us that 80 goes in the denominator, is 16, 16 goes in the numerator. Now we have a couple of options here. Let's look at one way of solving this is to go ahead and simplify this, because it turns out 16 goes into 80. So we can simplify that and say that x over 100 is equal to 16 over 80 is the same as 1/5. And then if you remember, our first approach to solving proportions was you can look at what do you have to do to 5 to get to 100. Well, you have to multiply by 20. And that means to go from 1 to x, you should also multiply by 20, and x is equal to 20. Okay, here's option 2. Go ahead and keep this, 16 and 80. This is, especially if you're using a calculator, you don't need to worry so much about simplifying, which is a pity actually, but we can go ahead and just cross multiply right away, so that we would have 80x is equal to 1600, and this one turns out to be so easy anyway, we didn't even really need to simplify to begin with. You're going to get the same result. X is equal to 1600 divided by 80 is simply 20. And now, does that make sense? Does it make sense that 16 is 20% of 80, or in other words, 1/5? Well, yes, we already showed that 16 over 80 simplifies to 1/5, so this is correct. What percent of 40 is 60? So again, we have x over 100, because we don't know the percent, of 40, means 40 goes in the denominator, is 60. Now notice here, the part is actually greater than the whole, or the part of the base is actually greater than the base itself, and that means we're going to end up with a percentage that's greater than 100. So if we go ahead and cross multiply, again you can simplify. 60 over 40 simplifies to 3 over 2, or you can just go ahead and cross multiply and get 40x is equal to 6,000, and so then we would divide by 40 to get x equals 150. So 150%. So we could say if we want 60 is 150% of 40, which makes sense because 150% means more than it's half again as much, and 60 is half again as much as 40. Okay, what number is 14% of 120? So here we already have our percent. 14% of 120 tells us the 120 goes in the denominator. What number is tells us that x should go in the numerator. So we can go ahead and cross multiply here, and we're going to get 14 times 120, which is, let's see, we're going to get 1200 and another 480, so that's 1680 is equal to 100x, and then we can just divide by 100, which is nice because that means move the decimal 2 places to the left, and we get 16.8 is equal to x. Does that seem reasonable? 14%. Well, 14%, let's see, that's a little more than 1/10 certainly. And 1/10 of 120 is 12. So we should have a little more than 12. 16.8 seems to make sense. Also, 120 is 1/5 again as much as 100. So our answer over here for x should be about 1/5 again as much as 14. And 1/5 of 14 would be, well, a little less than 3, since 3 times 5 is 15 rather than 14. And 16.8 is almost 3 more than 14. So this makes sense for a lot of different reasons. Okay, number 5. 48 is what percent of 128? So again, we're looking for the percent of 128. Means 128 goes in the denominator, and then 48 will go in the numerator. Go ahead and cross multiply, and we get 128x is equal to 4,800. Then divide by 128. And generally speaking, the directions will often tell you specifically, but generally speaking, we're going to round decimals to typically the nearest tenth of a percent. So here, if we go ahead and divide by 180, so we have 4,800, divide by 128, and we get 37.5. So in this case, we don't even have to round. So we have 48 is 37.5% of 128. Does that make sense? Well, 37.5% is a little more than a third, and 48 is certainly a little more than a third of 128. So it makes sense. It checks. He used the percent equation to answer the question. Remember, that one looked like this. A equals P percent times B, where we have of and is. So what percent of 115 is 37? Is 37 means 37 goes by itself. What percent? So we don't know the percent. Let's call it P. Of 115 means multiply by 115. So to get P by itself, we're going to divide by 115. So if we take 37 divided by 115, we get 0.32174, and I'm going to round it here, is equal to P. And now, two things. First of all, this is in decimal form. We need to move the decimal 2 places to the right to get percent, and also we're going to round to the nearest tenth of a percent. So that 1, we look to the next place over, that's 5 or higher, so I'm going to round the 1 up to a 2. So we're going to say 32.2%. Does that make sense? Well, that's a little less than 1/3, and 37 is a little less than 1/3 of 115. Seems reasonable. Okay, what number is 62% of 194? And so here we have what number is means we have x equals, we don't know the number, 62%, I'm going to convert to a decimal, 0.62. Remember to go 2 to the left to convert to a decimal, times 194. So of, again, tells us to multiply. And when we take 0.62 times 194, we get 120.28. So x equals 120.28. If we were asked to round to the nearest tenth, we would say 120.3. Okay, this is a little different type of an equation. This is a percent change. A high school had an enrollment of 1,254 students one year and 1,287 students the following year. Find the percent change in the enrollment. And the idea behind percent change is that we want to look at the new value minus the old or original value, and then always divide by the original or old value. So in this particular case, we're going to have the newer value is 1287 minus the original value of 1254, and then divide by the original value of 1254. So we had an increase of 33 students, 33 more students compared to the original value of 1254, and when we divide that, 33 divided by 1254 will give us 0.0263, etc., etc. And then to convert that to a decimal, or sorry, to a percent, I'm going to move the decimal 2 to the right, and I'm going to round to the nearest tenth of a percent, so 2.6%. And we know that this is an increase because we ended up with a positive change here. If you set this up correctly, where you're taking the new value minus the old, the sign will tell you whether there was an increase or a decrease. So if you get a negative result, that means there's a decrease, but because this is a positive 2.6%, we get an increase. So there you have some examples for solving percent problems. Good luck.